I'm so excited to see everybody here. I'm thrilled that we are all gathered here to talk about two of the great grasses that have come out of Texas A&M and University of Florida. And I'll start by saying thank you to King Ranch, Kevin, David, Hunter, and the entire team for hosting all of us. I want to thank Toby, Christian, South Solutions, their entire team for putting this event together. And I want to thank everybody who's here, because I know spring is a busy time of the year, and for you to take time and spend this morning with us to learn about these two new grasses, I'm really excited to spend time with you right now and hopefully after our talks are done and we go out to the farm and look at those grasses. And last but not least, I want to thank Dr. Kevin Kenworthy for his collaboration, for his collegiality. He picked us up at the airport yesterday, and we had a wonderful time visiting golf courses and sod farms. And this collaboration between A&M and University of Florida actually goes all the way back to 1960s, when the two universities worked together to develop and screen St. Augustine grasses that were resistant to SAD, St. Augustine decline, a viral disease. And that collaboration eventually led to the development and release of Floratam. So Floratam, Florida, Texas A&M, Floratam, right? And that was released in early 1970s, and it is the staple cultivar of, in the state of Florida, right? So very thankful for the collaboration, and I'm going to talk about some of the more collaborative work that we have done since, as I talk about Cobalt St. Augustine grass, which is one of the new releases from Texas A&M. And so the St. Augustine breeding project at Texas A&M began as a result of funding from the turfgrass producers of Texas, who about 20 years ago, they knew that in order for St. Augustine to remain viable in the state of Texas, we needed a drought-resistant St. Augustine grass. So they came to us with this ranked list of these traits. And the number one trait they wanted us to breed was drought resistance, followed by disease tolerance, insect resistance, turf quality, all the way to cold tolerance, which was ranked number 7. So with this list in mind, we started working on breeding new and improved varieties of St. Augustine grasses. A little bit on the genetics of St. Augustine grass, and bear with me, I'll try to explain this. So in St. Augustine grass, there are plants that are called diploids. They have 18 chromosomes. They tend to have good turfgrass quality, generally have good cold hardiness for St. Augustines, generally have good shade tolerance, and the cultivars would be like Raleigh, Palmetto, Amerishade, and so forth. Those are diploid cultivars. Now there are plants, a group of plants within St. Augustine's that are called polyploids, which have chromosomes more than 18. And they are a good source of resistance to traits like drought, disease, and insects. So obviously, in the breeding, we want to cross the two, diploids with polyploids, to bring the best of both into our new hybrids. Now, because of differences in the chromosome numbers, 18 versus more than 18, there is imbalanced pairing of chromosomes, which causes sterility. So what happens is, when you make the cross, the embryo is formed, but the endosperm in the seed that provides nutrition to that growing embryo is not fully developed. So if you leave that embryo on the maternal parent, it will abort. And so what we do in our program, use a technology called embryo rescue technology, which, as the name says, we rescue the embryo after making the cross, and we try to sustain its growth on artificial tissue culture medium in the lab. And we've been able to develop hundreds, if not thousands, of hybrids using this technology, where we've been able to take diploids and cross them to polyploids. Make sense? Okay. Here's the whole process of that embryo rescue technology. Here in the top picture, we are removing the pollen from a female parent. Here we are collecting pollen from the male parent, making the pollination. Here is that embryo that, or ovule that we are harvesting and putting it on tissue culture medium. And here's that new hybrid seedling. So these are called interploid, right? Between diploid and polyploid, interploid hybrids. They go to the greenhouse, out to the field for evaluation, production testing, expansion, so the whole process from start to finish. And Cobalt is embryo rescue derived interploid hybrid. So that is how Cobalt was developed. The cross was made in 2010. So another important thing that happened in 2010 was we were funded by USDA, Department of Ag, through a program called Specialty Crops Research Initiative Program, where these 6 universities, we all worked together to develop drought-resistant warm season grasses. And so the breeders, we developed the germplasm, we exchanged that germplasm and evaluated that germplasm in all these 6 different environments. And Cobalt was included in this study. So I'm going to show you some of the data from this study. The first one I'm going to talk about was done in Citra, Florida by Dr. Kevin Kinworthy and Dr. John Erickson and their team, where they looked at the performance of St. Augustine grasses under different irrigation regimes. So they looked at soil moisture sensor-based irrigation, in this case 8 times per month, so that's plots were irrigated twice a week, once a week, once every 2 weeks, once a month, and control is rain-fed only, okay? Again, I don't know how you can see pictures, but here's a comparison between Floratam and Cobalt visually, and this is during the dry period, so during spring season. I don't know, again, can you all even tell the difference? There's a little bit more green pixels in Cobalt than Floratam. This is during the wet period. You can see Floratam and Cobalt. Let me just go to the numbers, show data. So this is the data behind those pictures. So here you're looking at the performance of these different cultivars under those different irrigation regimes across 2 years. So anything that is in green here, so like here in Cobalt and Citra Blue, they maintained their quality above 6. So on a 1 to 9 scale, 9 being excellent, 1 being it's dead, 6 is the minimum acceptable quality, and both Citra Blue and Cobalt in this study maintained a quality of above 6 across those 2 years, and comparing that to Floratam, which is the industry standard. That's what we are comparing it to. Now, if we combine the data across those irrigation regimes and just break it down by year, again, so here are the cultivars. In 2018, you can see Cobalt was in the top statistical group 10 out of 10 times. So you're looking at by month data, and 9 out of those 10 times it had acceptable quality above 6. In 2019, Cobalt was in the top, Cobalt and Citra Blue both were in the top statistical group 11 out of 11 times, and Cobalt maintained its quality above 6 throughout the duration of that study. So I think this would be the most closest and relevant data because it is collected, it was from here in Citra, Florida. But again, both of these varieties are doing very well under drought stress, especially when you compare it to Floratam, which has been the industry standard. What you're seeing here is, this is a combined data from Dallas and Citra from that SCRI trials. And this is, so if you think about turfgrass quality, right, how does the grass appear under drought stress? So this is turfgrass quality under drought stress. This is data from Citra. This is from Dallas. What you're looking for are varieties that are in the top right quadrant, right? So that would mean that they had high turfgrass quality in Citra and in Dallas under drought conditions. This is the data showing turfgrass quality under non-drought conditions, so well-watered conditions. And again, this is Cobalt right there, Citra and Dallas, meaning it was in the top group. It was one of the top lines at both of those locations under normal conditions. And then if you combine the data between Citra and Dallas, this is quality, turfgrass quality under drought. This is turfgrass quality under non-drought conditions. And again, this is Cobalt regardless drought or non-drought, it was the top entry across Citra in Dallas. Okay. This is a really interesting way to look at this, genetic gain. So one of the unique features of this study was this was done across 9 different environments, and this study lasted for 12 to 14 years. So we had an ability to calculate genetic gain. Let me explain that. So you focus in on this little graph here. So the light gray bar here means turfgrass quality under drought conditions. Dark gray is turfgrass quality under non-drought conditions. And what you're seeing here is that Cobalt showed 51% genetic gain in turfgrass quality over Raleigh under drought conditions, and about 40% genetic gain in turfgrass quality over Palmetto. Under non-drought conditions, you're looking at 19% over Palmetto and almost 33% over Raleigh, a genetic gain in turfgrass quality. And so what that means is, this is huge. We are not looking at an incremental improvement. We are looking at a big step forward, a big advancement when it comes to quality under drought conditions over a long period of time. Right? This is, Cobalt was entered in the 2016 National Turfgrass Evaluation Program, NTEP program. So NTEP coordinates this testing across multiple environments in the US. So Cobalt was entered into it, and I'll show you some data. So 1618 is the experimental number for Cobalt. And what you're really seeing here is that, okay, so if you look at this first bar, in 2017, 50% of the locations that conducted NTEP test reported Cobalt to be in the top 25% of the entries. So it was in the top group in 50% of the locations that did the study. In 2018, you're looking at, I think, 55%, then 65% in 2019, and then 2020, it was, again, in 55% of the locations reported it to be in the top group. So 2 things that come out of this is, one, that it had much wider adaptation, right? Over 50% of the locations showed it to be more adapted to their environment. And 2 is that it consistently performed at a high level across those 4 years, right? So multiple years, multiple environments, it had a good top performance. So the question is like, okay, it is drought resistance. We think we achieved the goal that turfgrass producers of Texas put in front of us, but what does that mean to the end users? What does that mean in terms of how it can save water, right? So this is a study, this is actually a program called Water My Yard program. This was developed by Dr. Guy Phipps and Charles Swanson of Texas A&M Extension Service about 10, 11 years ago, where what they do is they use the local weather data to provide weekly watering advice. So how does that work? So in this program, these are the cities, municipalities, and water district in Texas that are sponsors or the partners of Water My Yard program. So any cities or residents within those cities can sign up for free, and they will get a weekly email saying, based on the local weather data, this is how much water you need to apply this week. And in order to apply this much water, you need to run your irrigation system for this long. So homeowners they get weekly emails using this Water My Yard program. So how does this work? Again, they use this equation to determine what that weekly water requirement will be. So ET, evapotranspiration, this is the data that you get from the weather station, right? You take that data, multiply it with a crop coefficient of 0.6, because we are working with warm season grasses, in this case St. Augustine grass, and then you multiply it by adjustment factor, which is depending on the stress level. If the homeowner is like, I want absolutely no stress on my lawn, well, then the adjustment factor is 1. All you're doing is multiplying evapotranspiration with crop coefficient of 0.6. But if you are able to tolerate a some level of stress, low stress 0.8, normal stress 0.6, high stress, very high stress of 0.4, then you apply that here, adjustment factor, and that calculates the amount of irrigation you need to apply. So in Water My Yard, they use normal stress as the calculation. So it becomes ET data from weather station times 0.6 times 0.6. That's how they calculate, and that's how those emails are sent out saying how much water you need to apply. So we did this study at the Dallas Center where we looked at 4 different adjustment factors, right? So we looked at irrigation at 80%, 60, 50, and 40. So low stress to very severe stress. And we evaluated these 5 cultivars: Tifway, Tifta, Bermuda, Raleigh, Cobalt, St. Augustine, and Palisades. And each one of these are replicated 4 times in each of these irrigation regimes. Here's the aerial view. So here you have all the different cultivars. And from right to left here, what you're seeing is increase in drought stress. So 80% to 40%. And then top to down, you are seeing increase in the duration of the drought stress. So first month all the way down to 3 months into the study. And so this here is least drought stressed. And if you go down here, this would be, right here, this would be most drought stressed, right? It's 40% after 3 months. Green means the plots are healthy, red means they are under drought stress. So if you compare Cobalt here across and then compare that to Raleigh, you see a bit more of red in Raleigh than in Cobalt, right? So when you convert those pictures into data, into numbers, this is what it turns out to be. If you're comparing Cobalt with Raleigh, under 80% adjustment factor, Cobalt never went below acceptable quality of 6. So it as compared to Raleigh, 105 days and 58 days. Now remember, these are in Dallas, heavy clay soils. You won't see these numbers here in Florida with the sandy soils. But in Dallas, in clay soils, we saw a big difference between Cobalt and Raleigh. So under moderate stress, Cobalt maintained its acceptable quality of 6 for almost 90 days, compared to Raleigh, 42, 56 days. Here is the data for high stress, and then under severe stress, you're looking at Cobalt maintaining its quality 50 to 56 days as compared to Raleigh for 20 or 34 days, right? So again, this is done in high clay soils, so you will not likely see these numbers here in Florida, but what you will see is the same trend, where Cobalt is going to retain its color and quality much longer than Raleigh or Palmetto. So if you were to convert that into water savings, you will be, let's say if Water My Yard recommendations, we keep it at 0.6, we will see better performance as compared to Raleigh. But if we were to adjust that adjustment factor from 0.6 to say 0.4, then you're looking at about 35 to 38% less water use on Cobalt as compared to Raleigh. Okay? So that's a lot on drought. Some of the work that we have done in our research plots and some of the things that we have observed. Very quickly, I want to talk about shade tolerance because, again, for St. Augustine grass, I mean, one of the reasons people grow St. Augustine grass is because of its shade tolerance. So how did Cobalt do for shade tolerance? This is a study that we did in Dallas, where in 2017 they were planted as plugs. In 2018, you can see they have formed plots, full plot here. This is the data. Each of these bars, okay, these are the cultivars here, percent green cover. Each of these bars mean how much percent green cover after 22 days, 33 days, all the way to 78 days after planting. So that's the end of year 1. And then we did continue to take data until 428 days after planting. These arrows here shows the end of first year, okay? So you see that all of these cultivars are growing, right? From that plug into plot, they're growing. But then some of these cultivars at this end, Delmar, Tamstar, Floratam, they never recovered from the winter stress under shade conditions. And we know for Floratam, it's not one of the most cold tolerant or shade tolerant varieties, and that's exactly what we saw, that it died under those conditions, whereas you can see some of the more shade tolerant varieties like Raleigh, Amerishade, Palmetto, they continue to grow, and so did Cobalt. It had about, 45% cover in year 1 and almost 80% green cover under shaded conditions in year 2, right? So what we have seen is Cobalt does have a shade tolerance similar to some of these shade tolerant varieties that are out there and better than Floratam. So this is my last slide before I give it over to Dr. Boyery. Some of the strengths and shortcomings, right? Nothing is perfect. Everything has shortcomings, and we need to know about those shortcomings so we can manage them as best as we can. So one of the things, it has intermediate spring green up between Floratam and Raleigh. So in our Texas environment, we have seen Cobalt to have more rapid green up than Floratam. But in the younger, newer plantings, we have seen Raleigh to green up faster than Cobalt. In mature sites, we have seen Cobalt to outcompete Raleigh because of its overall stress tolerance and persistence, right? So intermediate spring green up, better than Floratam, may not be as good as Raleigh. Similar response to large patch disease as Raleigh and Palmetto, so that's not an improvement. It's a similar response to large patch. Lethal viral necrosis, I know that's a major issue in Florida, and that is a little bit of an unknown at this point. I know Mark has worked on that. He has planted Cobalt in some heavily LVN infested areas. We've been watching that for a couple of years. We haven't seen any major issues as of right now, but it's, it's been in testing for a couple of years. Can't really come out and say definitively, but so far it's looking good. But that's all I have to say on LVN resistance. Maybe Mark has more to share. Herbicide tolerance. Again, we use a range of chemicals, right? And so this is something we are learning as we go. As people are trying different chemicals, we're finding out what's working, what's not. So that's something learning as we go. And then there are things that we don't know, right? So those are the unknowns. But the things that we know about Cobalt is that it has genetically dark green color. It just stands out in the plots. It has good turfgrass quality. It has lower water requirement as compared to Raleigh and Palmetto, lower fertility requirement that Dr. Boyery will talk about in a little bit. It has fewer pest issues than Raleigh and Palmetto. It has better shade tolerance than Floratam, better cold hardiness than Floratam. It has wider leaf blade. It has, like Floratam, more robust plant, and it has wide geographic adaptation. So as you saw, it was one of the top entries in the National Evaluation Program. So we are very excited about Cobalt. It's been in making for almost 15 years now. The cross was made in 2010. A lot of good work has gone behind it. A lot of good people have worked on this variety, and I'm really excited about the potential impact of Cobalt, especially when it comes to water savings. And I'm just thrilled to see all of you here with your interest in learning more about Cobalt. So, Dr. Boyery.